Hello, guys. Today we are going to be talking about denial of service or distributed denial of service, what is popularly known as DDoS attack. Now, what is a distributed denial of service? The word distributed simply means it is coming from multiple sources at the same time simultaneously, right? Now, let's take an example. Let's excuse me, please. So, a distributed denial of service is a situation where an attacker floods a server, right? They flood the server with more than the request the server can handle, thereby overwhelming the server and making it to be unavailable for reusers. So let me give you an illustration, right? Let's say there is an eatery or a restaurant around you, and the capacity of this restaurant, they have a maximum of, let's say, 10 chairs and two staffs, two waiters or waitresses. Now, these two staff can, if they have a full capacity, which is 10 chairs, right? If they have all 10 chairs occupied, it means that they can, one user or one staff can attend to 5 persons. That's what it means. So two of them can attend to the 10 persons. That's their maximum capacity. But now imagine a situation where um about 50 persons suddenly flood the eatery. Now there will be chaos. Why? Because number one, the chairs will not be enough. Number two, the two staff don't have what it takes to cater for the 50 persons, right? So what happens is that if these 50 persons are fake users, let's say they are maybe robots that just flooded the eatery, what happens is that when the real people who actually wants to eat try to access the restaurant, they are not going to be able to enter because fake users have already occupied everywhere, and eventually the service of the eatery is going to be halted. They are going to stop working. Why? For several reasons. One, they can't serve their food to bots. Number two, the two staff don't have the capacity to handle those much people that enter. It's the same way, right? So if your traffic, if your server can accommodate a total of, let's say, 100 requests, let me reduce this. Let's say total of 100 requests, right? So your server can handle 100 requests, let's say per minute, right? Then an attacker can flood that server with 10,000 requests per minute. So because of this spike in request, the server is now going to shut down, right? And mind you, these 10,000, they are fake users, not actual people. They are fake. So because they are fake users, when the real persons try to access the server, server become unavailable for the real users to access. That is what is called distributed denial of service. Now, or we call it DDoS attack, right? Now, this can be prevented by using what is called a load balancer, right? Now, a load balancer works like a shield. But let me draw an example. So this is your server, right? Let's draw. So this is a server, right? And like this. So this is a server. Pardon my drawing, please. So we have your server like this, right? So this is your server serving your users. So assuming you have two servers, right? So these are your users. Let's say a request is coming from this side directly to your servers, right? So request comes directly to the servers, right? So you have a way of syncing both the information on both servers together like this. Um, okay. So now when a user makes a request, that request goes straight to your servers directly, right? This approach, when an attacker decide to now flood your server with fake request, your server is going to shut down. Is that not so? Yes. But how do you prevent this? To prevent a DDoS attack, what we do is use what is called a load balancer, right? You use a load balancer. So a load balancer is like a middleman. So you put a load balancer here, right? So let's call it LB, a load balancer, like this. Now this load balancer, every request coming from the user end or the internet is going to be hitting the load balancer, not your server, as you can see. So the load balancer shields your server from direct access in the internet, right? So direct access in the internet is prohibited. All access is first of all reach your load balancer. Then the load balancer begin to distribute the request it receives to each of the server. So it sends some requests here and send some to this other side as well, right? So this is how a load balancer works. So your load balancer takes some request, sends it some here, sends some here. Now if the load balancer notices that this particular server is having let's say 80% traffic, right? 80%, this server is 80% used up. The traffic has gone up to 80%. But this one is around, let's say 30%, right? So this one is around 30%. It's going to stop sending much traffic here. So it's going to focus sending all other traffic to this point, because this one is almost filled up, but this one still have room to accommodate. So it's going to be sending more of the traffic here, as you can, you understand what I mean. So more traffics are going to be coming to this server. When the load balancer notices that this one is almost filled up, then this one will be taking much of the traffic. You understand the logic. So now when a user or an attacker floods your server with fake traffic, the load balancer is the one that is going to be receiving all that traffic instead of your servers. The load balancer is going to be receiving them. Now there is a downside to using only a load balancer, right? Remember, the load balancer work is to distribute the traffic across your servers, right? Although modern load balancers can reject traffic. However, if you want to really uh, if you want to really stop denial of service, what you do is you use your load balance, you combine the load balancer with other things. You combine it with things like web application firewall, right? So we have web application firewall. This is F. You combine it with web application firewall, where you can set some rules that determine what traffic gets to your server, right? You can set up some rules that determine what traffic the load balancer sends. So most of the traffic are going to be ending on the load balancer. Load balancer bounces them off without them getting to your server when you add web application firewall. Another way to save your server and protect yourself from DDoS attack is by applying rate limiting, right? So we are going to call it ROL for rate limiting. Now you can set up stuff like 100 requests per minute per IP address. So if a single IP address is requesting information from your server, or sending information to your server that is more than 100 requests per a minute, after 100 is going to stop until the next minute. That gives your server room to breathe, thereby avoiding DDoS attack, right? There are other ways you can also, other features you can implement into your load balancer. You can combine with the load balancer. But if you use web application firewall and rate limiting, that can go a long way for you, right? So this is a basic design, right? If you are planning to design a server that can withstand a DDoS attack and will not, we can easily scale. If you need any assistance, you can also reach out to us, and we'll be glad to help you to bring your server design to life, right? But take note, if your this load balancer, is it when you have more than one server that you should use it? Now, even if your servers you have just one, right? Even if you have just one server, it is recommended to use a load balancer, right? It is recommended. Yes, it is just one server. Regardless, implement a load balancer so that the load balancer can help you to manage the traffic, right? So this is LB for load balancer. So always use a load balancer, even if your your server is one. Now, when you add rate limiting to this, right? You add rate limiting and then web application firewall as well. Now, all traffic, the server is going to be queuing them. The load balancer, sorry, is going to be queuing them, especially when the server is busy. So off traffic are not going to be flooding your server. So even if your server is one, we still recommend you use a load balancer so that you don't experience a DDoS attack. So if you love this video, please share with your friends. Don't forget to subscribe for more exciting updates about the digital space. And don't forget to like, share, and subscribe. Turn on your notification bell so that you can get notified every time we drop new videos. If you have any questions or clarity, please use the comment section and someone will attend to you. Thank you for your time. See you in the next video.